I'm Carl Bostrom from Bosch Rexroth. I'm co-chair of PackSpec. My counterpart, Tom Jensen, couldn't be here today, and unfortunately he's the one with all the jokes. So it's going to be somewhat drier than it would have been. But
hey, come on, Carl, that was funny.
That was funny. That was, I worked on that all night, so that's really the extent of it. One of the features of PackML, and Jeff touched on this earlier, is that there's not a definite set of pack tags that will always be required in any one application. Even if we define a minimum set of pack tags, we still have optional tags. And because of this, we see PackML specification as a process, not a checkbox. We don't see that at any point in the future an end user will be simply able to say, give me PackML. There's more to it than that. The end user really needs to define exactly which pack tags he expects to see. In the base state model, he may expect to see certain states. He may not care about others, but there's a process there. It's much more than just saying, give me PackML. So the exercise that we're sort of in the process of going through involves creating a set of tools that will allow the end user and the machine builder to have that conversation. We're trying to put that conversation in the context of the overall machine specification. So that's what we're going to describe now in this presentation. So our immediate goal is to provide a framework for the overall machine specification process. We're not trying to specify anything here specific, but rather we're trying to create a framework for that specification process. One of the overreaching goals of OMAC is to emphasize form, performance, and functionality, so we've tried to lay out this framework in those terms. And the main point here is to try to understand how PackML fits into this process. So when you're specifying a machine, where does the PackML part fit? So that's the goal of what we're working on now. So we've defined what we're calling a PackSpec template. What we've done is to describe a series of steps that are involved on the part of the end user in creating a user requirement specification. So what components does that URS have? On the flip side, we take that same set of steps and view it from the point of view of the machine builder. So in this case, from the OEM's perspective, this would be something like a functional specification. So we want to try to harmonize these two different documents. On the one hand, the user requirement specification or the request for quotation, and on the other hand, this functional specification, to try to understand how these two documents can be harmonized, and then specifically to try to understand where in these two documents PackML needs to live. So these are the basic steps in our overall template. So introduction, what belongs in an introduction? When an end user produces a request for quotation, what are the sort of things that should be included there? Line overview, build specification, utilities, packaging materials, and so on. So these are the steps that we think are involved in creating that specification document. I'm not going to talk about each of these steps here. It'll take too long. But I do want to go through just the 4 listed in red. So these are sort of 4 key components of this. And the performance section and this interface section are what we're recommending as being the places where PackML fits in. So most of this, from our point of view, really has nothing to do with PackML per se. But we see PackML living in those two specific areas.
A question about your interface?
Yeah.
Is that a broad thing that's going to cover both the operator interface as well as the automation or interface to the other systems in the world?
We'll go through it in some more detail, but yes. So we're on the interface side. This is where we would include an HMI template if OMAC embraces a single template. That's where that template would live. But it also includes the machine-to-machine interface as well. So this is where we would expect the end user to define exactly which pack tags need to be supported by a particular machine. So we're sort of reserving that interface for the work that we're all doing now. So I'm going to go through these four components in detail. I should say that this template is on the ARC SharePoint now. We kind of consider it in a final draft form, so we're also looking for input from all of you now. Please read through it, get back to us with your comments. April 15th is a new deadline. Maybe that should be our deadline as well, to really produce a final draft of this document. I should also say up front that this is something we consider a first step. We thought this was a necessary exercise in trying to understand this problem, to really put PackML into this overall process. Maybe it wasn't necessary, but for us it was really a useful exercise. So let's just go through first the build specification and then the other 3 points in red. So in build specification, we're considering things like machine footprint, construction methods, material finishes, build standards, and so on. And the document itself, this PackSpec document, is divided into 2 distinct sections. First, we consider these points from the point of view of the end user. So in that case, footprint would be, my plant has this much space. Your machine needs to fit in that space. This is your maximum allowable window. From the OEM's perspective, if he's writing a functional specification, he needs to define how big his machine is. This is how I have a standard machine. This is its footprint. And that way, when this conversation happens, if both parties are using this outline, it'll be easy to sort of match up whether a given machine is going to work in a given instance. Construction methods would include things like welding standards, things like that. Material finishes is more obvious, but here we include things like do components need to be traceable? Do we have traceability certifications requirements and things like that? And then safety classification. So what are the requirements in terms of safety on the one hand? On the other hand, how has the machine been designed? What does the machine support? Performance, these things are more obvious. What are the machine speed requirements and so on. Here we want to stress that we use the metrics provided by PackML. So we want to encourage end users, when they talk about machine speed, to really refer to the associated pack tags that talk about machine speeds. We really want to start to introduce those metrics right away, up front in the user requirement specification. I think that will make the transition into the pack tag world that much simpler. Machine availability, process efficiency, this is really where so much of the pack tag information, this is really why we have so many of the pack tags that we do have. The interface part, this really is the PackML part. So here the end user really needs to define exactly which pack tags are supported or need to be supported. In a given mode, exactly which machine states need to be supported, and so on. The standard itself does not place any real requirements there. And even if we have a new standard which introduces a minimum tag set, because of those optional tags, we still have some work to do in terms of the end user getting exactly what he wants. Data transport, this is not something that we've necessarily talked about much. If PackConnect or when PackConnect comes out with a standard, we'll have to refer to that standard here. But until then, we need to talk about which protocols are going to be supported, exactly how this is going to happen. And then user interface, this would include things like the light stack. This would include things like an HMI template and so on. Another big emphasis in this template is to stress international standards, local standards, and so on. So we have placeholders for all these standards. The end user really needs to lay out exactly what's expected here. And as this document improves, we need to, or we will, expand this, refer to specific standards, and so on. But this part doesn't necessarily refer to PackML. We've included some appendices in this document that lay out some options for pack tag scope. And this part will be revised given the minimum tag set that's currently being considered by the PackML group. These are suggested scope levels. All we've tried to do is to group pack tags into concentric circles. So this OEE layer that you see in the document, this will be replaced by the minimum tag set that the PackML group is currently considering. But beyond that, we'll have a core set, which is slightly expanded, and then we'll list the full tags. The point of this is only to try to make this pack scope definitions problem more tractable. We're just trying to provide an aid. This would be a natural way to group pack tags together. So for example, if you're doing recipe management from the SCADA system, there's a set of pack tags that allows you to do that. So we would try to group those tags together. So this is just an aid. This is just meant as a way to sort of make this whole problem easier to manage. And the other thing we do in the document is to try to encourage the end users and OEMs to really define the state handling mode by mode. So in a given mode, exactly which states are supported and to provide some kind of overview about what's happening in those specific states. It's going to be a big problem if an end user expects to see a suspended state, but the OEM has decided in this mode I don't really need a suspended state. There needs to be a conversation about this, at least as the standard stands today. So just to summarize, this template is not a machine specification. It's meant as a framework for machine specification. It's meant as a resource aid, and we're trying to put the PackML part into this context, into the context of the overall machine specification. And here, we've defined this interface layer. So we've defined a part of this process where this PackML really should get inserted. I suspect if you look at this document, most of the end users here will recognize all of the steps. We're not saying to end users that they need to change what they're doing. I don't think that's our goal here. We're simply trying to provide a resource aid to maybe end users that are not so well versed or don't have these procedures in place. So that's it.